Hello, good morning to one and all. Today our topic discussion is our continuation of MapReduce functions. Today we are discussing the class that is nothing but MapReduce logical data flow. Okay, what I meant to say in the sense today, MapReduce logical data flow. First of all, if you have to learn about the MapReduce, what is a MapReduce? It is a software framework which supports parallel and distributed computing on large data sets. Previous class I already said you what is a MapReduce. It is a software framework which supports the parallel and distributed computing on very large amounts of data sets. It is nothing but MapReduce. Okay, first of all, if you have to take the input data to both the map and the reduce functions. Okay, the input data to both the map and as well as the reduce functions, it has a particular structure. What ma? It has a particular structure. So the input data to the map function is in the form of a key comma value pair. What is the form of map function ma? Key comma value pair. And coming to the output data, okay, we have to learn about now output data. The output data from the map function is structured. What ma? The map function is structured. We can take as a key comma value as a pairs called, we can call it as intermediate key or a key comma value pairs. What I meant to say in the sense, the output data from the map function, it is structured as key comma value pairs and it is also known as intermediate key comma value pairs. What we can define now, the user defined map functions, how it will be, the mechanism will be run. Okay, the user defined map function processes each input. What it processes? Each input like key comma value pair, and it produces a number of 0 and 1 or more intermediate key comma value pairs. What I meant to say in the sense, the user defined map function, how the processes to each input give a key comma value pair, and finally it produces a number of 0 and 1 or more intermediate key comma value pairs. Now we can discuss the reduce function. Okay, what the reduce function receives, what it achieves, the reduce function receives, it retrieves the intermediate key comma value pairs. It is in the form of a group of intermediate values. What I mean to say, reduce function, it retrieves the intermediate key comma value pairs. It is in the form of a group of intermediate values and it is associated with one intermediate key, and it is associated with one intermediate key like key of some set of values in a function. Okay, key comma some set of values, key comma value, no, in that value we have to take a set of values. Here we can denote the each key comma set of values, it's a group. It's a combination of a group. What it produces finally, a set of key comma value pairs as output. What I meant to say in the sense, we have to take some each key comma set of values group, it produces finally a set of key comma value pairs as a finally output result. So here our main goal is to process all input key comma value pairs. Okay, what I meant to say, our main goal is to process all input key comma value pairs to the what to the map function. What function we have to say? To the map function in parallel computing, as shown in the below figure. All of you look at this figure, otherwise you can't able to understand what I meant to say previously. Look at this diagram, all of you. I have to zoom this now. Okay, now we can clearly visualize. It's intermediate some pairs will be there if you have some keys and some set of values. Okay, and first of all if you have to take some input, and input what the map function will be taken, key comma value. I said already the key comma values, we want to take some map function. It's a line offset it line content will be there here, and we have to sort that key comma values, and that is performed in that MapReduce library. And coming to the group side, now you have to take some unique keys. Okay, unique keys, same key, single key, if you have to take some single key, unique keys, and the reduce function will be run at that reduce function side. Finally we get the output some key comma value. It is the diagrammatic representation of key comma value of pairs. What I meant to say in a sense, MapReduce is oriented around key or value pairs. What the framework will convert here, each record of input into a key or value pair, and each pair will be input to the map function once, and then the map output is a set of key or value pairs. Nominally we can say the one pair that is transformed input pair. Okay, and but it is perfectly acceptable to output multiple pairs. Okay, now we can see the map output pairs are grouped and sorted by key. Okay, so the reduce function is called one time for each key and in sorted sequence. Okay, now we can see with the key and the set of values that shape that key. Okay, now we can say the reduce method here. What the reduced method, it may output an arbitrary the number of key or value pairs which are written to the output files in the job output directory. Okay, now we can see if the reduce output keys are unchanged from the reduce input keys. Okay, so the final output will be sorted. Now what I meant to say in the sense, the framework provides two processes that handle the management of MapReduce jobs. First one we have to say, first process task tracker. In the sense it manages the execution of individual map and reduce tasks whatever they given on a compute node in the cluster. Okay, once again I have to repeat, the task tracker, it manages the execution of individual map and reduce tasks on a compute node in the cluster. And coming to the second process, we have to learn about the job tracker. In the sense it accepts some job submissions and it provides some job monitoring and control and manages the distribution of tasks to the task tracker nodes. That is the concept of intermediate key or value pairs. Okay, now we have to learn about what is the strategy to solve MapReduce problems. What is the strategy? Look at this, all of you. What is the strategy to solve MapReduce problems? What I meant to say in the sense, strategy, what strategy we have to solve at MapReduce problems in the sense, after if you have grouping all the intermediate data, okay, and the values of all occurrences of the same key or should be sorted and grouped together. After grouping each key, it becomes unique. Each key becomes unique in all intermediate data. Therefore we can finding the unique keys is the starting point to solving a typical MapReduce problems. How we can solve a typical MapReduce problems in the sense, once again I have to repeat this, all of you listen carefully. After grouping all the intermediate data, if you have grouped all the intermediate data, the values of all occurrences of the same key. If you have to listen carefully, the values of all occurrences, what ma? The values of all occurrences of the same key, or it should be sorted and it is grouped together. Now we have, after grouping, now we can see in the each key it becomes unique. What ma? The each key it becomes a unique in all intermediate data. In all intermediate data, the each key becomes a unique. So therefore we can say, we can finding a unique keys is the starting point. What I mean to say, therefore a finding unique keys is the starting point to solving a typical MapReduce problem. What we want to solve a typical MapReduce problem, we have to solve each key become unique in all intermediate data. Therefore we can find out finding a unique keys is the starting point, okay, to solving a MapReduce problems. Now first of all, if you have seen one diagram, and then it will be easily understandable you. Then the intermediate keys, in the sense you have no intermediate pairs, what then the intermediate pairs key comma value as the output of the map function, it will be automatically found. Now we can see the problem 1 now, okay, what the problem 1 will be, okay. Now we can see the problem 1, we have to counting the number of occurrences of each word. How the number of occurrences of each word in a collection of documents. What the solution, what the question, what the problem will be there, counting the number of occurrences of each word in a collection of documents. Okay, in a collection of documents we can counting the number of occurrences of each word. What the solution, you have, if we have to identify the unique only unique key, okay, each word and intermediate value. What I meant to say, unique key as well as each word and intermediate value and number of occurrences. Now we have to look at this diagram, otherwise we can't able to understand. Listen carefully this diagram. Here we have to learn about the figure illustrates you the overall MapReduce word count process. What ma'am? The figure illustrates you the overall MapReduce word count process. Word count process. The name says the word count process. Some mechanism the word count will be there. First of all, if you have to take some input like dog, cat, rat, okay, and one more, if you have to take car, rat, okay, and then if you have to take a dog, car, cat, if you have to split at each one at one blocks, okay, one block if you have to take at each one, if you have to splitting this, first one if you have to take a dog, cat, rat at one block, and coming to the second block a car, rat, and third block dog, car, cat. For example, if you have take any words, okay, now we have to do the mapping process. What we have to do at the mapping, dog 1, cat 1, rat 1. Here if you have to give some mapping, okay, car 1, for example, car 1, rat 1, and then if you have to take a dog 1, car 1, cat 1. Okay, now if you have to do the shuffling, the dog, where the dog will be there, if you have to take some shuffling, okay, dog here, dog 1 here is there, and if you have to take some third block, dog 1 is there. If you have to move and give some straight arrow mark for dog 1, first block, and if you have to take some later car 1, okay, where the car 1 will be located in second block, if you have to 2, and the third block 1, if you have give some arrow marks like that, if you have give cat 1, and rat 1, and then we have to reducing these tasks at unique ఒక single గా వచ్చేటట్టు you have to reduce, in the sense you have to degrade it, you have to decrease that. Dog, how many dogs? 2, and car will be 3, and cat will be 2, and rat will be 2. Finally, you have to the final result output of the final to generate the output result. Finally, what that car 3, cat 2, dog 2, rat 2. This is the final, this is the overall map reducing the word, each word count process will be done like this. Okay, now we have to learn about MapReduce actual data and control flow. What I meant to say today, what I meant to say, now we can discuss MapReduce. Okay, MapReduce actual data and control flow. What I meant to say today, MapReduce actual data and control flow. We can learn about what is a MapReduce. It is a software framework which supports a parallel and distributed computing on a very large amounts of data sets. Sorry. Now we can learn about the main responsibility. What the main responsibility of the MapReduce? MapReduce main responsibility of the MapReduce framework. It should be efficiently run on a user's program. On a what is to efficiently run a user's program on a distributed computing system. For that purpose, the MapReduce uses the following steps. What the main responsibility of the MapReduce framework is to efficiently run a user's program. Okay, efficiently run a user's program on a distributed computing system. For that purpose, the MapReduce uses the following steps. First one, if you have to learn about, first one is data partitioning. What we have to learn now? Data partitioning. What we have to learn now? Data partitioning. Data partitioning. What in the sense data, the name says exactly data should be partitioned in the form of what? Okay, now we can see the MapReduce library. It splits the input data like files into m pieces that also correspond to the number of map tasks. Okay, what I meant to say in the sense, the MapReduce library, it splits the input data like files into m pieces that also correspond to the number of map tasks. Okay, now we can do a second point, that is nothing but computation partitioning. Computation, what we want to compute and manage the software requirements. Okay, what we have to handle, this is implicitly handled by obligating the users to write their programs in the form of the map and reduce functions. What I meant to say in the sense, this is implicitly handled by obligating the users to write their programs in the form of the map and reduce functions. And coming to the third one, that is nothing but determining the master and workers. How we can determine the masters and workers? First of all, the MapReduce architecture, it is based on a master worker model. What the MapReduce architecture is mainly based on? Master and worker model. Okay, one of the copies of the user program, you can, the user will be write some program. If you have to take one of the copies of the user program, it becomes the master and the rest becomes workers. Okay, what I meant to say, the user program becomes the master and the rest becomes workers. Okay, and the rest become workers. Now we can see the master picks idle workers. What the master, the user program becomes the master. Already I said you, the master, what the picks idle workers. Idle workers, the master picks idle workers and to assign the map and reduce tasks to them, and to assign the map and reduce a task, some work to allot them. Okay, and coming to the final point, a map reduce worker, it is typically a computation engine. What I meant to say in the sense, a map reduce worker, it is typically a computation engine, such as like we can say some cluster node. What node? Cluster node, to form a group, to group something. Okay, like node to run map or reduce tasks by executing map reduce functions. Finally, what I meant to say in the sense, a map or reduce worker is typically a computation engine such as a cluster node to run map or reduce tasks by executing map or reduce functions. Finally, we can fourth step, what you can do, you have to reading the input data. In input data, if you have like data distribution will be there. Okay ma, reading the input data, what we have to read, reading the input data. Like if you have to take data distribution, what the data will be distributed to others. Now we have seen in step 4, reading the input data. Reading the input data, if you have to take some data distribution, if you have to take in the diagram, each map worker reads its corresponding portion of the input data. Exactly what the map worker do, in the sense he reads, the map worker reads it's a corresponding portion of the input data, and namely the input data split and sends it to the mainly you can what the and namely the input data, if you have to do the splitting, the input data it should be splitted and sends it to the map function, and sends it to its mapping map function, and sends to its map function. What I mean to say here, the reading the input data like a data distribution. Now the each map worker reads its corresponding portion of the input data, and namely the input data it should be splitted and sends it to its map function. Okay, this is the concept of map reduce actual data and control flow. Now we can see the actual data and control flow in further steps also. Okay, now we have to learn about coming to the map function. What is meant by map function? Okay, here the each map function receives what it receives, it retrieves the input data split as a set of key comma value pairs to process and produce the intermediate key comma value pairs. Easily understandable this point, we have to listen carefully. Each map function receives the input data. Each map function it will be received the input data, whatever you have to split as a set of key comma value pairs to process and finally to produce the intermediate key comma value pairs. Coming to the step 6, combiner function. What is meant by combiner function? This is an optional local function. What ma'am? This is an optional local function within the map worker which applies to intermediate key comma value pairs. What I meant to say, in the sense it is also an optional location function within the map worker which applies to intermediate key comma value pairs. So the combiner function merges the local data. It merges the local data of each map worker before sending it over the network to effectively reduce its communication cost. What I mean to say, in the sense the combiner function links the local data of each map worker before sending it over the network to effectively reduce its communication cost. Okay, now we can set to be synchronization. What is synchronization? It will be synchronized. Okay, the MapReduce, for example, the MapReduce applies a simple synchronization policy to coordinate the map workers with reduce workers, in which the communication between them it starts when all map tasks finish. Okay, this is the concept of synchronization. Once again, I have to repeat clearly. MapReduce function, it applies a simple synchronization policy, simple synchronization policy, it applies to coordinate the map workers with reduce workers. What ma? To coordinate map workers with reduce workers, in which the communication between them, after the starts when all map tasks finish. Okay, this is the concept of synchronization. And coming to the sorting and grouping, what is meant by sorting? Sorted, some set of elements it should be sorted. And coming to the grouping, some set of members it will be grouped, like that. Some set of rows, some set of columns, whatever it may be. Now coming to the map reduce function, the reduce worker, what they do, the reduce worker groups intermediate key comma value pairs by sorting the data. It is based on their keys. Okay, and followed by grouping all occurrences of identical keys. This is the concept of sorting and grouping. First of all, the reduce worker groups intermediate key comma value pairs by sorting the data based on this based on their keys, and followed by grouping all occurrences of identical keys. Okay, now we can learn about reduce function. Reduce, what we have to reduce in that function? The reduce worker iterates it through looping, iterate in the sense looped, in the sense it iterated. Okay, the reduce worker iterates over the grouped pairs like key comma value, and for each unique key and it sends the key and corresponding values to the reduce function. What I meant to say in the sense, the reduce worker iterates over the grouped keys, grouped pairs like a key comma value, and for each unique key, and it sends the key and its corresponding values to the reduced function. Then this function processes gives its input data and stores the output results in predetermined files in the user's program. What I meant to say in the sense, reduce function, finally the reduce worker iterates over the grouped pairs like a key comma value, and for each unique key, and it sends the key and corresponding values to the reduce function. Then this function processes its input data. Okay, then this function processes its input data and stores the output results in predetermined files in the user's program. Okay, now we have to, this is the concept of map reduce actual data flow and control flow. Later we discuss the design of Hadoop file systems. Okay ma, later we want to discuss design of Hadoop file systems in later video. Thank you ma.